Bismillahirrahmanirrahim. I am Dr. Javed Iqbal Kokar, Professor of Forensic Medicine and Toxicology. And as we have started the Thanatology, and this is the third lecture of this topic. And the contents of today's talk will be that I will be discussing what is alger mortis or cooling of the body and how it progresses. Then the cooling of metallic object, because the human body does not behave like a metallic object, so we have to differentiate between these two phenomena. Then what is thermometer, how we record the temperature of the dead body, and what are the factors which affect the rate of cooling. Then what is postmortem caloricity. So starting with the topic, thanatology, as we discussed the changes after death, and we know that they are the immediate changes, early changes, and the late changes. The immediate changes are actually at the moment of death, which are the signs of death. And the early changes are the changes which appear after some time. And like the contact flattening, then the cooling of the body, alger mortis, postmortem staining, which is livor mortis, and rigor mortis, which is the postmortem stiffening of the body. So these are the early changes. So taking first the contact flattening. Contact flattening is the flattening of the surface of the body which is in contact with the surface on which it is lying. And this is because of the loss of tone in the muscle, because of the loss of innervation. There is loss of tone in the muscles, and because of the effect of the weight of the body being transmitted on the surface on which it is lying, the body surfaces which are in contact, they become flattened. So that is contact flat. And it can easily be manifested or can be appreciated when the post-mortem staining develops, because uh, the contact flattening areas which are in contact, because of the weight, the blood does not flow into those areas, and in between the contact areas of contact flattening, the postmortem staining will be well evident. So that will distinct what are the areas of contact flattening and which are the areas of postmortem staining. So you can see the reddish area, it is because of the postmortem staining, and the normal color skin because of the weight, it is the contact flattened area. Now we start discussing with the cooling of the body or the alger mortis. This is the earliest sign, and we know that during life the balance of temperature being generated is maintained by heat being produced and heat being lost. So a balance is maintained between the production and the loss, and the body phenomena or body mechanisms, they keep the body temperature at 37 degrees Celsius or 98.6 degree Fahrenheit. But after death, there is no heat production, so only there is heat loss. And this heat loss is gradual, because only when the gradient will be established from the body to the environment, then the loss will start. And normally we know that for heat loss there are three mechanisms: radiation, conduction, and convection. But for dead body, the most important is the conduction. That means the surface on which the body is lying, from that contact, the body will lose its heat, and that is the conduction. So, disappearance of the heat of the body is one of the earliest signs, and low temperature can also be because of the death or because of hypothermia, and we have to make distinction between these two. During life, the normal temperature is 98 degrees 6 Fahrenheit or 37 degrees Celsius, and this temperature is maintained for some time after death, and the core temperature or the inside temperature is maintained because there is no heat loss, and the insulating factors of the body tissue, they are keeping the heat inside. So for some time the body will maintain its temperature. And human body does not cool in accordance with the Newton's law. And Newton's law is the cooling curve for the inanimate or metallic object. And Newton's law states that the rate of loss of heat anytime is directly proportional to the temperature difference between the surface of the object and the surrounding. So it's a gradient, the loss from the body to the environment, that is proportionate to the temperature difference. So this Newton graph for a metallic object is a simple exponential type. That means it shows initially there is a slow progressive fall, and initially there is rapid fall, and then there is slow progressive fall as the object approaches to the environmental temperature. So here you can see it is exponential. Initially for a few hours it is rapid, and then when the body approaches to the environmental temperature, the loss is slower. The human body does not behave like metallic object. We should understand this. What does this mean? Because we know that human body is not composed of a uniform uh, uh, tissue or uniform matter. So it is made up of various tissues, and there are fluid, there are gases, there are solids like bones, muscles, fat, subcutaneous fat, and the skin. So they all have variable conductivity of heat. The covering fat, the subcutaneous fat, and the skin, they act as insulator, and they are poor conductor of the heat. So the body surface cools rapidly than the center of the body, and the core temperature or central temperature of the body remains unchanged for first few hours because of these insulating factors. So always the core temperature should be taken for the purpose of estimation of time since death. The rate of cooling of the body is generally accepted as most dependable criteria for estimation of time since death, especially for initial 12 to 18 hours. Now how the cooling progress? You can see this graph is a sigmoid shape. Initially A is showing a flat line that body is maintaining its temperature for a few hours, then B that there is a rapid fall, and then the C that showing the slower fall. So this, the outer layer up to 2.5 centimeters thick skin, subcutaneous fat, they have got insulating properties. So relatively cooling of the interior body takes place A. It little loss will be initial few hours, which is shown by A. And at this time the body temperature is preserved, and it is also because of the chemical changes which are going within the body. That means some heat production is going on, and it depends upon the glycogen content of the muscles. Then anaerobic glycogenolysis will be going on, which will be sufficient to raise the temperature. So the metabolic process does not cease at the moment of death, but anaerobic glycolysis, that the anaerobic processes, they carry on. And this is the factor which is responsible for contributing the maintenance of initial plateau, maintenance of the temperature initially. So this is because of postmortem anaerobic glycogenolysis, and this can produce 140 calories, which is sufficient to raise the temperature of the body 2 degree to Celsius to 3.6 degree Fahrenheit, and this is for the initial 3 to 4 hours after death. So these 140 calories which are created or generated by the anaerobic glycolysis is sufficient to raise the body temperature for initial 3 to 4 hours for 2 degrees Celsius or 3.6 degree Fahrenheit. So that's how this graph is showing. Then the part B, next 6 to 9 hours, the skin temperature fall and the heat gradient is established between the environment and the body, and then there is rapid fall. Then after the 12 hours, the C is showing a slow fall. That means now the body is approaching the environmental temperature. Gradient is less. The difference of heat, transfer of heat is less. So the heat will be now losing at a slow rate. That is shown by C of the graph. So this is the whole graph, a sigmoid shape, A, B and C. Now, how we measure the heat loss in the dead body? So, for the recording of the temperature of the dead body, thermometer is used. Thermometer is a special thermometer which is marked from 0 to 50 degrees Celsius, and it is to measure the postmortem temperature called thermometer. The clinical thermometer, measurement of the temperatures with the thermometer, they are kept in the mouth or the axilla and the temperature is recorded. While at autopsy or in the dead bodies, the temperature is measured from the rectum. That is, the rectal temperature is taken. So normally the rectal temperature is the best. It is 1 degree Celsius higher than recorded from the mouth. Then in some time the subhepatic or vaginal measurement can also be made. But in certain situations, a special precaution has to be taken. I'll discuss that. So while recording temperature, the temperature is recorded that the thermometer is inserted, the thermometer is inserted into the rectum for 3 to 4 inches, and it is kept there for 2 to 3 minutes, and as the temperature varies from place to place, you take 3 to 4 readings and do not disturb the thermometer and keep it lying there for 2 to 3 minutes. At least 4 readings are taken at approximately half an hour interval to determine the rate of cooling. Now, it is said that no matter how accurate the measuring of the instrument may be, the how to collaborate the procedure for determining the time since death is not a reliable criteria. Even then, the rectal temperature at the time of death can never be known, because to know the exact rate of fall, we should find out what was the temperature of the rectum at the time of death. Then, when you record later on, then you can estimate. So, the rectal temperature should be recorded immediately when you receive the body, as early as possible. Now, regarding the important precautions, if there is any possibility of sexual assault, intercourse, homosexuality, or exosexuality, no interference should be done. So the clothing and the perineum, they should not be disturbed until the other forensic examination or the collection of trace evidences has been completed. So you should not take, in these situations, the rectal or the vaginal temperature should not be taken. And the Other trace evidences like the semen, hair, fibers, they are collected first. And in these situations, the subhepatic temperature is recorded. A small incision is made in the right hypochondrium and the thermometer is inserted below the liver and subhepatic thermometer temperature is recorded. Now the method of calculation of temperature, how we calculate? Hourly calculation, and there is Newton formula that average fall is equal to 1.5 degrees Celsius per hour. So hourly not as reliable, not applicable. So the rate of loss of heat is directly proportional to the temperature difference between the surface of the body and the surrounding. So the required data for the calculation of temperature is that we should know what was the body temperature at the time of death, what was the cause of death, what is the temperature of the environment, and what is the temperature of the seat of the body, that is the temperature of the surface on which body is lying. So these are the other uh, things which we should know. So it has been estimated that under average circumstances, the fall may be approximately 1.5 degrees Celsius per hour, plus minus 2 degrees Celsius, keeping in mind the cooling curve. So other criteria are more reliable. So temperature from estimation of time since death, temperature is not as reliable criteria as others. So different formulas has been devised to determine times is that the Glaister and Rentol they devise certain formulae that the 98.6 degree minus rectal temperature divided by 1.5 will give you the hours. Then the Mashal and Hoare formula for an unclothed body it is for the first 18 hours. For first 3 hours, the fall is 1 degree Fahrenheit per hour. Next 3 hours, 2 degree Fahrenheit per hour. Next 2 degree Fahrenheit, and next 3 hours, 1.5 degree Fahrenheit per hour. So during next 12 hours to 15 hours, it is at the rate of 1.3 degree Fahrenheit per hour. They have estimated from various experiments. Generally, the body cools at the rate of 2 degree Fahrenheit for the first 6 hours and thereafter 1 degree Fahrenheit per hour till it attains the environmental temperature. So, there are certain factors which influence the rate of cooling. There are factors within the body and there are factors outside the body. The factors within the body, they are the body temperature, body size factor, state of nutrition of the body, and presence of clothing, and mode and manner of death. Then the factors which are outside the body, it depends upon the location where the body is lying, the movement of air, the ventilation, the humidity, and the environmental temperature. Now, regarding the body temperature, for this we should know what was the temperature at the time of death. And usually it is assumed in normal deaths that it is the normal temperature. Whereas this can be subnormal or this can be above normal. For example, if the victim is exposed to extreme cold, then there should be hypothermia. And if the death is due to congestive cardiac failure or excessive hemorrhage, secondary shock, the temperature is subnormal. And sometimes the body temperature is raised because of infection, spontaneous hemorrhage, death due to heat stroke, or in asphyxial death, and death where the agonal period is prolonged. And if death is due to fulminating septicemia, the body temperature may continue to rise several hours even after the death. So while calculating the postmortem period from the rate of cooling, all these possibilities should be kept in mind. So these are various situations showing various temperatures in different situations uh, at the time of death. Now the body size factor, this is usually assessed that the size of the body is basically it is the ratio between the surface area to body mass, and if it is more, then the nourishment is more and the uh, loss is greater. Effect size factor is greater in having heavy nutrition. Similarly, the state of nutrition, the small body cools early and the large body cools slower, and depends upon the mass and the surface area. That is, the surface area, if it is larger, it will cool easily. If it is small, it will cool at slower rate. So cooling is a relatively slow because of more fat if the body is large, and which is a poor conductor of heat, whereas in child and small body the rate of cooling is rapid than the adults. Then presence of clothing. The presence of clothing makes the heat loss slower, and absence of clothing make it faster. So the effect of cooling in presence of clothing is that the rate of cooling fall in rectal temperature is about 66% than that of the naked body. So it has been experimentally seen that the naked body loses 66% faster than the covered bodies. Then depending upon the mode and manner of death, if the glycogen content of the muscle has already been exhausted because of the activity of muscle before death, then the heat production by glycogenolysis during the stage of molecular death will be minimal. And if the death is due to hemorrhage, then the heat loss will be, uh, it causes heat loss with the blood even prior to death. So the heat loss is slower in chronic bacterial diseases. Heat loss is faster in wasting diseases. Then location of the body, where body is located. Body is exposed to air movement. It is in the room. It is in the open field. So it depends upon where the body is lying. Inside the room, loss or no air, and there will be slow cooling. And in open, when the exposed to air, there will be rapid cooling. And when the body is in fluid medium, whether it is water, is a better conductor of heat than air, so the rate of cooling of bodies in the fluid will be faster than the air. So the temperature of fluid is also important. In cold water, it cools rapidly, and in hot water, it cools slowly. Then the nature of fluid, dirty water, cooling is slow because the dirty water, because sewage water, they are warmer than the plain water. Fresh water, the cooling is rapid. And in sea water also the cooling is rapid. Then the flow of water in running water, the cooling is rapid. And in stagnant water, the cooling is slow. Then the humidity, the moist air, they are better conductor than the dry air. So it will be rapid in moist air. And in dry air, it will be less. Similarly, the environmental temperature is depend upon the heat loss depends upon the gradient of the body temperature and the environmental temperature. So if the environmental temperature is higher, then the rate of fall will be slower. And if the environmental temperature is low, then the rate of fall will be faster. But in our country, in winters, the temperature is low, but in summers, the temperature is higher than the body temperature. So it will be rapid in winters and slower in summers. Now the postmortem caloricity, that is gaining heat. Instead of losing heat, body gains heat after death. In certain conditions, instead of losing heat, the body gains heat. And this is because if the environmental temperature is high or in septicemia. So in these conditions, the body temperature continues to rise for several hours after death. Other situations are uh, which in which the body temperature is higher than normal, high grade fevers, sunstroke, pontine hemorrhage, encephalitis, lobar pneumonia, typhoid fever, strychnine poisoning, tetanus, and many other diseases in which the temperature at the time of death is higher. But in septicemia, the body temperature continue to rise even after death. So thank you very much. This is all about uh, the cooling of the body.